Today we are taking a few more examples on integration by parts. Remember the formula. The integral of u dv is equal to uv minus the integral of v du. Let's take an example. Evaluate the integral of e raised to the power 2x cos 2x dx. Here, let u be cos 2x and dv is e raised to the power 2x dx. That means u is cos 2x, which implies that du is minus sine 2x dx, and dv is e raised to the power 2x dx, which implies that v itself is e raised to the power 2x over 2. Therefore, the integral of e raised to the power 2x cos 2x dx is equal to uv, which is cos 2x times v, which is e raised to the power 2x divided by 2, minus the integral of v du, which is e raised to the power 2x over 2 times du, which is, or if u is cos 2x, the derivative of u is actually minus 2 sine 2x. So that's times du, which is minus 2 sine 2x dx. And that means 1 over 2 cos 2x e raised to the power 2x plus 2 here 1, 2 here 1, that's plus the integral of e raised to the power 2x sine 2x dx. We can say that this is another product. This is another product of two functions, which we are also going to integrate by the integration by parts formula. So here, u is sine 2x, and e raised to the power x, e raised to the power 2x dx is dv. E raised to the power 2x dx is dv. So that means 1 over 2 cos 2x e raised to the power 2x plus uv, which is sine 2x multiplied by v, which is e raised to the power 2x over 2 minus the integral of v du, which is e raised to the power 2x over 2, and du is times 2 cos 2x dx. So 2 here 1, 2 here 1, and then we have 1 over 2 cos 2x e raised to the power 2x plus 1 over 2 sine 2x e raised to the power 2x minus the integral of e raised to the power 2x cos 2x dx. And that means the integral of e raised to the power 2x cos 2x dx is equal to 1 over 2 cos 2x e raised to the power 2x plus 1 over 2 sine 2x e raised to the power 2x minus the integral of e raised to the power 2x cos 2x dx. When we collect like terms, we have the integral of e raised to the power 2x cos 2x dx plus the integral of e raised to power 2x cos 2x dx equals 1 over 2 cos 2x e raised to power 2x plus 1 over 2 sine 2x e raised to power 2x, and that means 2 times the integral of e raised to power 2x cos 2x dx equals 1 over 2 cos 2x e raised to power 2x plus 1 over 2 sine 2x e raised to power 2x, and therefore the integral of e raised to power 2x cos 2x dx is equal to the whole of this right hand side divided by 2, and that's times 1 over 2, which is 1 over 2 times 1 over 2 cos 2x e raised to power 2x plus 1 over 2 sine 2x e raised to power 2x, which is equal to 1 over 4 cos 2x 1 over 4 cos 2x e raised to power 2x plus 1 over 4 sine 2x e raised to power 2x plus c. Don't forget the constant of integration. You could have even put it here, plus c. And that's it simply. We take another example. Evaluate the integral of x cubed e raised to power minus x dx. Here u is x cubed and dv is e raised to power minus x dx. So that's equal to u, which is x cubed, multiplied by v. V is the integral of dv. That's the integral of e raised to power minus x, which is minus e raised to power minus x, minus the integral of v, which is minus e raised to power minus x du. If u is 3x squared, then du will be, if u is x cubed, then du will be 3x squared dx. 3x squared dx, which is equal to minus x cubed e raised to power minus x plus 3 multiplied by the integral of x squared e raised to power minus x dx. Let me make sure I'm writing my x properly. And that's equal to, we can see that this is another product of two functions. So we use the same integration by part formula to evaluate it. Here u is x squared and dv is e raised to power minus x dx. So that means minus x cubed e raised to power minus x plus 3 times uv, which is x squared. V is minus e raised to power minus x, which is the derivative of e raised to power minus x, minus the integral of v, which is minus e raised to power minus x du, which is 2x dx. That's equal to minus x cubed e raised to power minus x. And we have plus 3 into bracket minus x squared e raised to the power minus x plus 2 times the integral of x e raised to the power minus x dx, and that's the same as minus x cubed e raised to the power minus x minus 3 x squared e raised to the power minus x plus 6 times the integral x e raised to the power minus x dx, which is equal to, this is another product of two functions, so this is u and this is dv. So we continue, minus x cubed e raised to the power minus x minus 3x squared e raised to the power minus x plus 6 times uv, which is x into bracket. Let me use this kind of bracket here. uv x into bracket v, which is minus e raised to the power minus x minus the integral of v du minus e raised to the power minus x du is dx, since u is x, and that's equal to minus x cubed e raised to the power minus x minus 3x squared e raised to the power minus x plus 6. Can I open the bracket? Okay, let me do it in 2 steps. Plus 6 into bracket minus x e raised to the power minus x plus the integral of e raised to the power minus x dx, and that means minus x cubed e raised to the power minus x minus 3x squared e raised to the power minus x minus 6x e raised to the power minus x plus 6 times the integral of e raised to the power minus x dx, and that's equal to minus x cubed e raised to the power minus x minus 3x squared e raised to the power minus x minus 6x e raised to the power minus x plus 6 times minus e raised to the power minus x plus c, and that's equal to, which is equal to, therefore the integral of x cubed e raised to the power minus x dx is equal to minus x cubed e raised to the power minus x minus 3x squared e raised to the power minus x minus 6x e raised to the power minus x minus 6 e raised to the power minus x plus c. And that's it, simply. Let's take maybe a last one. Evaluate the integral of 2x ln x dx. Here we can see that if we make ln dv, if we choose ln x dx as dv, we're going to have a problem because we won't be able to find its integral. We cannot find the integral of ln x, but we can find the integral of 2x. So we're going to choose ln x as u because we can find its derivative, but we can't find its integral. So it's better chosen as u, and the rest, which is 2x, will be dv. Now when we integrate, we have uv, which is ln x times v is the integral of 2x, which is 2x squared over 2 minus the integral v du, which is 2x squared over 2 2x squared over 2 times du. Du is 1 over x dx. And that's equal to 2 here, 2 cancels 2, 2 cancels 2. And then we have x squared ln x minus the integral of x here cancels one of the x's here minus the integral of x dx. And that's equal to x squared ln x minus x squared over 2 plus c. So this is x squared. Therefore, the integral of 2x ln x 2x ln x dx is equal to x squared ln x minus x squared over 2 plus c. And that's it simply. The most important thing is that you choose a variable which has a derivative which is simpler than itself as u, and the rest of the products will be dv. And wherever you see that dv is non-integrable, then you choose it as u instead of dv. You must make sure that whatever you are taking as dv is integrable. If it's non-integrable, then you choose it as u and the rest as dv. So once you're able to make the right choice of u and dv, it's going to be very, very easy to evaluate the integral by integration by parts method. That's it simply. I hope you enjoyed the video. Thank you very much for watching, and please subscribe to this channel if you have not already done so, and hit the bell icon to be notified, to get notifications whenever to be notified as soon as another video is uploaded. Thank you very much, and wish you the best of luck in your math exam, in your examination. God bless you.